Thank you, everyone. Thank you, everyone, the organizers, and everyone who is in attendance. So, during my first event at Just Eat, a couple of months ago, I had free drinks, free pizza. So I thought, well, just eat. Maybe you don't have to pay anything. The second time at Monzo, a few months ago, was my second event. I had free pizza and drinks again. And I told myself, hey, maybe next time you have to contribute something, pay for this. And because I believe that learning is sharing, I'm here today to share with you a very important topic. My name is Sunday, and one of the best things we can share as gophers is how we build servers that behave politely. They start fast, finish fast, and know when to stop. And that is exactly what today's talk is about, using context in Go servers as a guide to best practice. How many of us, not how many of you, how many of us have forgotten to cancel context in our applications before? Pretty much everyone. So I'm new to Go, and I'm excited to share what I have learned in about a year writing Go. So why context matters? As we all know, it manages timeout and cancellations and deadlines, prevents leaks in Go routines, enables graceful shutdown and tracing, and is also the core to Go's concurrency model. It goes beyond just cancellation. It's for control. It enables, it allows us to have a kind of coordination between our Go routines. So imagine you have multiple Go routines running. It's been a common mistake. I've seen a couple of applications or code bases where most people seem to not totally understand how this works and what it is meant for. So, understanding the basics. So every context starts with the root context, which is context of background, and context of to do, which is basically, it has similar behavior, pretty much similar with background, but to do just serves as a placeholder for the developer for future context may be unknown at a point in time. So from the root, we can now derive any other context, which is timeout or cancel. So as a best practice, it's always the best argument in any function, not as optional argument, as that could easily mess up application. So I've got a little code snippet here that shows context in action. So we've have context as first argument, and we also use the select statement here to listen to to know when the context has been cancelled or times out. So this is a basic approach that pretty everybody knows. And the first, in the first case, we have time.after. So time after is just a function in time package that returns a channel which delivers time or duration when it has elapsed. So that channel closes. So that demonstrates a successful operation. But because we have passed context down, we've propagated context down to this function, it now gives us the flexibility of deciding when this process terminates. It could be in a network request, it could be in database calls. Once you can manually signal this process to terminate, and this helps to efficiently manage resources. For instance, you have a network connection that is open, and you want to reuse resource when the process has finished. So imagine having to have multiple connections open without knowing. A user closes browser, request should end, all operations should end. So the moment you cancel or the timeout elapses, then context.done so the select is away through the context.done. So from there you can return. So I also have time-bound operations. So this also is an example of use case of with timeout, which is also obtained from the context package. So fetch remote is a function that makes a network request. And because we have also propagated context down to this, it's also easy to set timeout for the request that we are making. So this is actually one of the things implemented differently in different programming languages. So when I started writing Go, it was somehow easier to do using third-party libraries in other languages. So it took a while to figure out how this could be done efficiently. So every network or IO operation should have a timeout. It's a rule of thumb. So we accomplish this using with timeout. Sorry. So the next slide. So this is a kind of more detailed implementation of our fetch remote, where we have new requests with timeout on the HTTP package. So this method, sorry, with context, not with timeout. So this allows us to bind the existing context with that of the network request, allowing us to also cancel all operations on demand. So with this, whenever we signal from outside or from the calling instance where we are making this request, we can easily also cancel apart from just the timeout which we have set. And this automatically cancels the remaining operation. Even if network request has been made, the response body is being read. So this is already wired to be context aware, and it automatically cancels and returns. So one other common use cases of context is also to pass values around. So this is also one of the ones that is commonly misused. So it's not a data bag, and it's also meant for request scoped metadata, not to carry heavy struct and other payloads around. So we don't, it's not recommended to store large structs or mutable state in it. So in HTTP handlers, database, and external requests, every request handler in Go already has a context on the request type. So it's a good practice in handlers to use request.context and not request.background. So that context tracks when the client disconnects. For instance, when user browser closes. So all operations at that point should be terminated for efficient management of resources. And this is also context with timeout when querying database, similar to that of making external request. So when to use context or background, in most of the code bases, when I started Go newly, I saw context background at every point. So in all functions, people declared a new variable, context background, and pass it around. So it became a confusion because I didn't understand the need. After all, without that, my application was still working. So yeah, so this is the root context, which is used at the boundaries, main, test, initialization stage. So we don't use it inside handlers. Rather, we propagate if we need. But request handlers already have come with context, so we don't need this. So even if it's empty and doesn't have deadlines, cancellation, it provides a route for structured cancellation. So can think of it as apps foundation. Every timeout's built on it. So one of the most important part, or most interesting part to me, is doing the concurrent task. So as a best practice, I know that different people have different techniques and methods to manage this. But this package, Hero Group, simplifies the whole thing. So you don't need any manual wait groups again or Hero channels to listen for when done or a channel is closed. So if you use this, it helps you to bind all goroutines to a common context, meaning that it forces all goroutines to terminate automatically as soon as one fails. So if there is a timeout in one or context, any error in context, it terminates all. So this is structured concurrency in action. And so this is code snippet. It is very basic, but could have a lot going on there. So similar to the way we used to start goroutines. This one has the error group with context returns a group and context. So the group now has a method go, which starts any function passed to it in a new goroutine. And this error here returned from the function, the inner function, is what tells the error group when to terminate all goroutines. So once the very first function or goroutine returns an error, then all other goroutines will be cancelled, and that error is what will be returned. This is one of the tests, a very simple one, a basic one, to simulate cancellation, manual cancellation, and timeout. Yeah, it's a very simple one. So we have the function run up, which is similar to the process that we have earlier. And the time after is to simulate a delay of 100 milliseconds. So if I call this function, when I call the function, I pass my context. If the timeout to that context is less than this 100 millisecond here, then there will not be a successful operation, because there will be a timeout before 100 milliseconds. Otherwise, it completes and returns nil. And for this one, the next function is test is manual cancellation, just like you cancel even before executing that function, and it doesn't do anything. It returns immediately because you canceled it earlier. Yeah, and that is just screenshots of the test when I ran the code. So testing cancellation, pretty easy. Simulate timeouts on manual cancel calls. Deadline exceeded vs deadline canceled, you know the difference. Have good tests to ensure goroutine, no leaks, goroutine leaks. This pattern helps validate timeout configuration in real services. So in summary, context controls life cycles and deadline. Propagate context everywhere. Don't invent your own cancel flags. Cancel early when work finishes. Never leak goroutines. Then use error group for structured concurrency and context hierarchy. So there is already with timeout calls in 1.22, Go 1.22, which is useful for further debugging to know what the cause is. Can integrate tracing via OpenTelemetry, which uses the same context chain. And context isn't just a cancellation token, it's glue holding concurrent system together. Thank you.